Here we go. We're going to take another antiderivative, and we have the antiderivative of negative secant squared of x over 3 dx. And I guess you might want to rewrite this a little bit first if you think this is a quotient of functions, because it's, well, I guess it kind of is, but really negative 1/3 is just a constant. So we have negative 1/3 times the secant squared of x dx. So we can actually bring that constant out in front. So we have negative 1/3 times the antiderivative of the secant squared of x dx. So now we know that that constant is just going to hang out. So now we can look at these formulas over here, or we can just ask ourselves, what function's derivative is the secant squared of x? Well, if you know your derivatives, you know that the derivative of the tangent of x is the secant squared of x. So that's how I think of those. It's much easier than memorizing. Well, you should memorize these formulas, but anyway, here it is right here. K in this case would be 1, but regardless if you're using the formula or not, you should always think what function's derivative is, the integrand is what we call this term right here, by the way, if anyone really cares. But you should, but anyway, that's what it's called, just kind of like you call it the radicand, what's under the radical. What you're integrating, the function you're integrating, you ask yourself what function's derivative is this function that I'm integrating. So in this case it was secant squared, so the function whose derivative is secant squared is the tangent of x. So that's it, and we'll go on to the next one.